morning friends, I am back again with one more video lecture on the topic linear differential equations of higher order with constant coefficients. Now the general form of the linear differential equations of higher order with constant coefficients is dny over dxn plus k1 times dn minus 1y over dxn minus 1 plus k2 times dn minus 2 y over dxn minus 2 plus dash 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 plus k and y is equal to capital X, and this equation is denoted by 1. Now here dependent variable y and its all derivatives occur in the first degree and are not multiplied with each other. Therefore it is a linear differential equation. Now where this k1, k2 up to kn are constants and this right hand side capital X is either a constant or a function of x only. Now if this right hand side, if this capital X is 0, then equation 1 becomes dny over dxn plus k1 dn minus 1y over dxn minus 1 plus dash 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 plus kn times y is equal to 0. Now this equation is denoted by 2 and is called homogeneous differential equation. Now if x not equal to 0, then ordinary differential equation 1 is called non-homogeneous differential equation. Now operator d, now denote this d by dx, means this differential operator, means this derivative d by dx stands for capital D. Therefore d2 over dx square, this stands for d square, and dn over dxn, this stands for dn. So therefore dy over dx is equal to this capital dy, d2y over dx square is equal to d square y, and dny over dxn is equal to dny. Now here the symbol, this d is a differential operator. Now the equation 1 can be written in symbolic form, can be written dn plus k1 dn minus 1 plus dash 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 kn times y is equal to x. Now we denote this polynomial by f of d times y is equal to x, where this f of d is equal to this d to the power n plus k1 dn minus 1 plus dash 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 plus kn. That is, this f of d is a polynomial in d. Now here the operator d can be treated as an algebraic quantity, and the polynomial f of d can be factorized by ordinary rules of algebra, and the factors may be written in any order. Now we will discuss the linearly independent solutions. For n functions y1, y2, yn are said to be linearly independent if c1y1 plus c2y2 plus cnyn equal to 0 implies this all ci is equal to 0. That means c1 is equal to c2 is equal to this cn is equal to 0, means all ci are 0. And if at least one ci not equal to 0, then the given functions y1 to yn are said to be linearly dependent. In other words, two functions y1 and y2 are said to be linearly independent one is not the constant multiple of other, or this y1 upon y2 not equal to constant. For example, sin x and cos x are linearly independent because this sin x upon cos x not equal to constant, and e to the power x and e to the power 2 times x are linearly independent because again e to the power x upon e to the power 2 times x, this is equal to e to the power minus x, this is not equal to constant. Now we will discuss some theorems regarding solutions of non-homogeneous differential equation and homogeneous differential equation. Theorem 1. If y1, y2 up to yn are n linearly independent solutions of the differential equations dny over dxn plus k1 dn minus 1y or dxn minus 1 plus kn y is equal to 0. This equation is denoted by this small one, and this is homogeneous differential equation. Then this u is equal to c1y1 plus c2y2 plus cnyn is also its solution, means solution of differential equation 1, where c1, c2 up to cn are arbitrary constants. Now proof. Now since this y1, y2 up to yn are solution of equation 1, so therefore this one implies, means this y1 satisfies the given equation 1, similarly y2 and yn also. So dn y1 over dxn plus k1 dn minus 1 y1 over dxn minus 1 plus dash 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 plus kn times y1 is equal to 0. Similarly, this y2 is a solution of equation 1. So therefore y2 satisfies the equation 1, that is dn y2 dxn plus k1 dn minus 1 y2 over dxn minus 1 plus kn y2 is equal to 0. And lastly, this yn is also a solution of equation 1. So therefore dn yn over dxn plus k1 dn minus 1 yn over dxn minus 1 plus dash 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 plus kn times yn is equal to 0. Now these equations are denoted by number 2. Now we prove that this u is also solution of equation 1. So therefore dnu over dxn plus k1 dn minus 1 u over dxn minus 1 plus dash 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 plus knu is equal to, now this dn over dxn, and now here this u is equal to c1y1 plus c2y2 plus dash 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 plus cnyn plus k1 times dn minus 1 over dxn minus 1, and again this u be the c1y1 plus c2y2 plus cnyn. Kn times u be the c1y1 plus c2y2 plus cnyn. Now simplification of this. Now this c1 be the common, c1 times this dn y1 dxn plus k1 times dn minus 1 y1 over dxn minus 1 plus so on, plus this kn times y1, here this c1 be the common term, kn times y1 plus Now similarly, this C2 be the common term, plus C2 dn y2 dxn plus k1 dn minus 1 y2 or dxn minus 1 plus dash 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 plus kn y2 plus this cn be the common term dn yn dxn plus k1 dn minus 1 yn or dxn minus 1 plus this kn yn. From equation 2, this bracket is equal to 0. Again this bracket is equal to 0 and this last bracket is equal. From equation 2, c1 times 0 plus c2 times 0 plus cn times 0, and therefore this overall calculation is equal to 0. Now which shows that this u is equal to c1 y1 plus c2 y2 plus cn yn is also the solution of homogeneous equation 1. Now since this solution contains n arbitrary constant and therefore it is the general solution or complete solution of equation 1 of homogeneous equation 1. Now one another theorem, theorem 2, if y is equal to u is the complete solution of the equation f of t times y is equal to 0, so this is homogeneous differential equation, and y is equal to v is the particular solution, that means this particular solution containing no arbitrary constant. So here y equal to v is a particular solution of the equation f of t times y is equal to x. This is non-homogeneous differential equation. Then the complete solution of the equation f of t times y is equal to x is y is equal to this u plus v. Now it's proved. Now since this y is equal to u is the complete solution of the equation f of t times y equal to 0, is the complete solution of f of t times y is equal to 0. So therefore this u satisfies this equation, that means f of t times u is equal to 0 and it is denoted by 2. Also this y is equal to v is a particular solution of f of t times y is equal to x. This is non-homogeneous differential equation. So therefore this v satisfies this equation 3, means f of t times v is equal to capital X, it is denoted by 4. Now adding 2 and 4, adding 2 and 4, so f of t times u plus f of t times v is equal to 0 plus x. We write this as f of t times u plus v is equal to capital X. So therefore this u plus v, that means we denote it by y, this u plus v satisfies the equation 3, satisfies the non-homogeneous equation 3. Hence this y is equal to u plus v is the complete solution of equation f of t times y is equal to x. Yes, this u contains the n arbitrary constant, therefore y is also contains the n arbitrary constant. Now most important part, now the part y is equal to u is called the complementary function, and simply it is denoted by C dot F. Now here complementary functions means complete solution of homogeneous differential equation, and the part V is called the particular integral of the equation f of t times y is equal to x. Now in short, CF means complete solution of homogeneous differential equation f of t times y is equal to 0, and pi particular integral means particular solution of non-homogeneous differential equation f of t times y is equal to x, and therefore the complete solution of non-homogeneous differential equation f of t times y is equal to x is this y is equal to complementary function plus particular integral. Thus, in order to solve non-homogeneous differential equation f of t times y equal to x, we first find the complementary function, that is complete solution of homogeneous differential equation f of t times y equal to 0, and then the particular integral, that is a particular solution of non-homogeneous differential equation f of d times y is equal to x. Hope all of you have understood this topic, linear differential equation of higher order with constant coefficients. In the upcoming lecture, we will discuss method of finding the complementary function. Please subscribe the channel and let me know your comments and feedback. Thank you.